All right, this video is on sign conventions. So sign conventions are extremely important in this unit, especially when we're working on multiple choice. So first of all, delta G being negative, we all know that that means that the reaction is thermodynamically favorable. In some of the older free response questions, you'll see the word spontaneous in place of this. You just need to know that spontaneous and thermodynamically favorable means the same thing. However, now we must use that word thermodynamically favorable when we're justifying things. Also, if you remember from your electrochem unit, if my delta G is negative, then my E cell is positive. And you'll see that down here at the relationship between delta G, K, and E cell. And we'll get to this in just a minute. I want to skip over to delta G being positive. If delta G is positive, then that means that the reaction is not thermodynamically favorable, or we can say thermodynamically unfavorable. Either one is acceptable. In electrochem, this is where E cell would be negative. And again, we are going to focus on that in just a minute. Now what I want to do is go back to this middle bullet here. If delta G is 0, then that means that the reaction is at equilibrium, and E cell, we learned the dead battery would also be at 0. I want to take a moment and just talk a little bit more about something conceptually when delta G is at equilibrium. So it's true, when we're at equilibrium, delta G is 0. So where does this come into play for thermochemistry? Well, anytime we're going through a phase change, all right, a phase change is when you have some substance going from one phase to another. So let's just say you have element X here, or compound X, and it's going from a solid to a liquid. You will see these equilibrium arrows more than likely. That's indicating that you are at equilibrium, or you have an equilibrium present there. So anytime I see a phase change, that means I'm at equilibrium, and therefore delta G is 0. Well, where this applies is I can plug this 0 delta G into delta G equals delta H minus T delta S equation. And if I plug a 0 right here, this equation is going to rearrange in which I have a negative delta H equals a negative T delta S. Well, those two negative things cancel out. So what I end up getting when I rearrange that formula properly is delta H is equal to T delta S. So what I can do with this equation, several different things. I think on one of your entropy and free energy practice problems, you had to solve for delta S. But this equation is most widely used to figure out what temperature must be involved in order to have a phase change going on. So I would plug my delta H value in, plug my delta S value in, and I could solve for my temperature there. So that is an important concept to know when we're dealing with a phase change. Remember, phase changes are at equilibrium, so that means your delta G is equal to 0. So what I want to do now is go through this bottom portion where it's the relationship between delta G, K, and E. I want to come back to here and do this last because that is a very important concept. So this is stuff that we learned last unit, and so this will be reinforced again in this unit. If delta G is 0, that means I'm at equilibrium, so my equilibrium constant is 1, and my E cell value is 0. If my delta G is negative, that means my E cell value is positive and my K value is greater than 1. That means that my products are favored here. If my delta G is positive, then that means I have a negative E cell and my K value is less than 1, which indicates that my reactants are favored. Remember, the reason why products are favored for negative delta G is because that means thermodynamically favorable. That reaction happens on its own, so I'm making my products. The reason why, if delta G is negative, that my reactants are favored is because if that reaction has a positive delta G, that indicates that my reaction is thermodynamically unfavorable. And that means that my reactants are staying reactants. They're not producing those products. So that's why reactants are favored. So those are the different relationships between delta G, K, and E. Very important. They love to ask that question in multiple choice. What I want to refer to now is conditions of delta G. Now, where this is being applied is our delta G equals delta H minus T delta S equation. Minus T delta S. So I can predict signs for delta H, predict signs for delta S, and plug all of those values in. Well, if I know the sign of delta H and delta S, I can predict on what the sign of delta G will be, and that's what this chart is for. I advise you not to memorize the chart, instead make sense of it mathematically. So let's start with this first scenario. If my delta H is negative, so I have a negative value right here, and my delta S is positive, let's see if we can figure out what delta G would be. So I have a negative quantity here, a minus a positive quantity here. So you see how it's a negative essentially plus another negative. So what that is telling me is that my delta G will be negative. It doesn't matter what temperature that is present there, because my temperatures are always going to be in Kelvin, so they're more than likely going to be positive values. So that's what this line is saying here. If I have a negative delta H value and a positive delta S value, my delta G will be negative or thermodynamically favorable at all temperatures. If I'm dealing with, let's see if I can erase this here. If I'm dealing with a positive delta H and a positive delta S, temperature is going to be a factor in that scenario. So let's plug those values in. Let's say delta H is positive, delta S is positive as well. So overall right here, we get a positive quantity. Over here, we get a negative quantity because it's a negative for positive numbers. So it really depends on which side is greater than the other. If my T delta S is greater than my delta H, then that means my delta G will be negative. But if my delta H value is greater than my T delta S value, that's going to indicate that the delta G is going to be positive. So when we have the same sign and they're both positive, we say that delta G will be negative, thermodynamically favorable at high temperatures only. That's because if I have high temperatures, that's going to make this value, T delta S, greater than my delta H value, which will make my delta G negative. All right, so if delta H is positive, delta S is positive, I only have a negative delta G at high temperatures. If I'm dealing with a negative delta H and a negative delta S, then temperature is a factor there as well. So let me see if I can erase a little bit of this, and we'll go from there. So what we're looking at is negative delta H and negative delta S. So delta H is negative, delta S is negative as well. Now, what will happen mathematically? Well, I have a negative quantity here, a negative and another negative makes a positive. So it really depends on which value is greater. If my delta H value is greater than my T delta S value, then that means my delta G is going to be negative. But if my T delta S value, you see how the negative and negative is going to make a positive, is greater than my delta H value, then that means my delta G would be positive. So that is why in this scenario, when delta H is negative, delta S is negative, we say that we are thermodynamically favorable, delta G will be negative only at low temperatures. Because if I have a low temperature right there, what that is indicating is that my delta H quantity will be greater than my T delta S quantity, which will make my delta G negative. So the key here is if they have the same sign, temperature is a factor. If both the signs are positive, you only have a delta G at high temperatures. Delta G of negative at high temperatures, I should say. If both delta H and delta S are negative, then that means I will only have a negative delta G at low temperatures there. Now, last scenario, if delta H is positive and my delta S is negative, temperature does not need to be a factor there. The reason why is because this quantity is positive. A negative and a negative is going to make this quantity a positive as well. So no matter what my temperature is, my delta G is always going to be a positive value. So if delta H is positive, delta S is negative, you will never have a reaction that is thermodynamically favorable. Doesn't matter what the temperature is. So delta G will always be positive in that case scenario. So working with these sign conventions, the conditions of delta G, this is an extremely important concept. So please make sure you really understand it. Don't just memorize the chart. Apply it to delta G equals delta H minus T delta S, and hopefully that will get you through majority of your multiple choice.